Okay, this video I'm going to show you how to do a SOPAS record using the Speetec from SICK. I am connected here on SOPAS, so if I just go into the configuration of the device really quickly, I am connected to one of the programmable versions of the Speetec. So I just want to make sure that the configuration is good. So right now I just have the Speetec hovering over a conveyor, so I don't need muting or a digital trigger. So make sure those are off, and then reset cumulated link. Doesn't really matter. What I'm really after whenever I'm testing this in an application are these three values: the speed, the retroreflection error, and the signal to noise ratio. There is, if you hover over the eye, it kind of tells you more information about what it is and for a good test, what you want that value to be. And it has those for both the retroreflection and the signal to noise. So those are going to be the critical bits of information, again, when you're testing this in an application, to make sure it sees the target material reliably and works well in your application. And then I am going to also monitor speed. So if I wanted to test this in an application, I could have it running underneath and just watch these values. However, the device itself is spitting out information a whole lot faster than SOPAS is going to be able to display it. So if that is the case, depending on anything that you have connected on SOPAS, you can do a SOPAS record, a data recorder. So down at the bottom on the main project screen, down at the bottom, there's a data recorder tab. If I hit that tab, I can go into the gear, and then here's where I can click browse. I can set up, and I've already done this, as you can see. I'll just set up a new folder, and then really critical on this, you want to change it from a data file to something else. So I'm just going to make it an Excel file and hit save. It already exists because I've already done this before. Yes, I want to replace it. And now I can say I want to take a reading every however many milliseconds. So I think the factory default is going to show 100. You can change this to whatever you want. Once a second, once every 10 seconds. I'll just leave it at 50 milliseconds. So once I hit record, every 50 milliseconds, it's going to record whatever data I select below. And as I mentioned before, I want the speed. So I'm just going to type in speed. Oh, look, it's already checked. And I also want the retroreflection error. And I believe that starts with RR. There it is, RR per second. I already got that checked. And then now the signal to noise, so I think that's SNR, and that's already checked as well. If you want to know what's been checked, you can filter over on the left-hand side, and it shows me those three things. Now, you don't have to type anything in the filter. You can just click through. Depending on the sensor, if it's an IO-Link sensor, there's going to be a check mark next to all process data. It'll have a lot of other information you can select, but if you just want the process data, you can do that as well. But for the Speetec, right now, I'm just concerned with those three things. So click, once that's done, click OK. And then now I'm going to turn my conveyor on and just hit record. Yes, I want to overwrite existing file because I've already done this before. And then now you can see as it's recording, it tells me how much time has elapsed, it tells me how many records I have. So it's every 50 milliseconds. So I'm getting a lot of records out of this. During the setup, let me just go ahead and hit stop. During the setup, you could change it. You could say a maximum record time. So if you just want to set this up and walk away after a certain amount of time and not let it get too many records, too much data built up, you can set a maximum record time. But I'm just going to go ahead and do this again. Overwrite it again. Let it run for a little while. I'm going to throw a piece of paper in there as well, just to see how it affects that signal to noise ratio and if I'm getting any retroreflection errors out of this. And go ahead and stop it there. Once that's stopped, I can go to where I had my file. Okay, and here's the file that I get. So it gets a timestamp. It gives me the retroreflection error right here. It gives me the signal to noise ratio and then the speed. Now there are some formulas that you have to put in here to make this make sense. So for the speed, in meters per second, the formula is the speed that it gives you times 12.5 divided by 2 to the 23rd. If you really want to know where this formula came from, I'm sure I can figure that out. But we'll just leave it at that. So that's the formula to get the speed in meters per second. And if you watched the video earlier, this is about the speed that I was getting. So now I can just kind of fill that all the way down. The retroreflection error is going to be 0 for most of this stuff. But if you are getting, well, because I'm looking at a matte black target, so I'm not really going to get any retroreflection errors. But if you divide that by 1,000, that's going to be the data in percentage. So if I was getting any percentage here, that would show up there. And then the signal to noise ratio is what it is. So I think in SOPAS itself, when it talked about those readings, I'm going to go back here. When it talked about these signal to noise ratio, that it's preferable to be over 300 for best performance or best accuracy. And then retroreflection error less than 1%. So going back to my data, that signal to noise ratio is less than 300. And you can see it jumped up here. So that's my white piece of paper. So this is an easy setup if you want, again, if you wanted to get a lot of data and you're running a pretty fast test and the data is coming through quickly and you can't really rely on SOPAS. Using a SOPAS record is a really good way of doing that. So let us know if you have any questions.